Write everything down that's on the poster you're going to need today and tomorrow. You should recognize some of it. 5.2.
You doing work?
Whatever. Alright, this is 5.3. Learning how to graph sines and cosines. Where is everybody? Ethan's gone. Chandler? Is Chandler here?
That's your job. I bet you do, bro. Yeah.
Blake? Blake's gone? Both Blakes? Okay. Copy down, let's go. Why aren't you copying that down?
I can't see it.
Up, amplitude. There are already videos for this lesson, but again, I'm making videos for whatever we do in class. Okay. So you're going to need this for a whole bunch of stuff. It's just kind of a step-by-step process to help you, because it really isn't in the book like this. And it's really pretty easy to graph trigonometric functions, especially if you know this stuff. And it's stuff that we've had before. You remember how to graph different functions, shifting and reflection. It's the same, exact same type of thing. Alright? So we're going to start with the sine function. I'm going to start with something very simple so you can figure this out. So you're supposed to know your unit circle. Please don't give it out. I don't want to see it ever. You should know this. So this is 5.2. Graphing functions. I'm not sure what the title of it is, but that's what we're going to do, trigonometric functions. So I want to do sine of theta here. Okay? So you tell me, if we were to take the unit circle and lay it out flat, we would call that our t values, okay? You can say x-axis is fine. And then we have our y values here, okay? And I'd say, okay, what happens on the sine trigonometric function when we start at 0? So what is the sine value at 0? What is the y value when t is 0 on your unit circle? Think about what your unit circle is. When t is 0, we're right here. What is the y value? 0. So the sine function actually starts at the origin. Okay? Again, I told you need to make sure you're practicing this stuff. Make sure you know it. Now, the next part of this was pi over 6, and then pi over 4, and then pi over 3, and then we had pi over 2. These three are closer together because they're only 15 degrees apart in 30 degrees on each side. So that's kind of how that graph is going if you're going to make an accurate graph. So what is the sine of pi over 6 at 30 degrees? What is the y value? I'm waiting on you. Y value.
1/2.
1/2. It's a short leg, isn't it? So that's 1. 1/2 is right here. At pi over 4, what's the y value, everybody?
Square root of 2 over 2.
Okay, so at the top of your paper, write square root 2 over 2, and use your calculator to tell me what value that is as an example. We need to know what that is. And you're going to use this over and over again, so we need these values. Yeah. Square root 2 over 2, what is it? What? 0.71, right? Is it 0.70 something?
Yeah, 0.70.
Alright, well while we're at it, let's do the square root of 3 over 2. What is that value, please? Yeah, 0.87. We'll just stay with that. Alright, so these are values you just need to make sure you remember, okay? You're going to use them as you go around this unit circle. So again, at pi over 4, you said that was the sine of pi over 4 is square root 2 over 2, which is 0.71. So now we go up a little bit higher. And the sine value at pi over 3. What's the y value at 60 degrees? What is that?
Square root of 3 over 2.
Square root 3 over 2, which is 0.87. And then at pi over 2, everybody, what is the y value? Positive 1. So here we have how the sine value is graphed. Instead of a circle, going around and seeing what the values are, we can get the values by looking at a graph. Okay? And then we go on. So instead of going on, instead of getting these other ones here, I'm going to go ahead and split this all up. Make this into fourths. We're going to end at 2 pi, which should be at 0, right? The y value of 2 pi is 0, where we began. Okay? And this value is pi, and this is 3 pi over 2. So instead of making you go through and plotting all these points, I'll help you a little bit. It's a 2-hour delay. We've got a short period, so go through this a little quicker. Who remembers does anybody remember what the sine function looks like? Did you guys graph these at all? I assume not. The other class said no. Okay, so at pi, what is the y value? What's the y value? 0. So it has to come back down here. And if you were to graph these three in here, 2 pi over 3, 3 pi over 4, 5 pi over 6, you would get these same values here. Okay, so this is a nice, neat half circle, basically. Okay, and then if you graph everything here, 3 pi over 2, we are at this point. What's the y value?
-1.
-1. So we go down to -1 here. And then up to 2 pi, you said goes to 0. So this is the shape of the sine curve. And then it starts over again. It repeats. And goes another 2 pi. And then another 2 pi. And the same thing if we were to go left. -2 pi, it would continue this direction, okay? The sine wave just goes on for infinitely many times. We call this the period for the sine curve. The distance from beginning to end before it repeats. That's called the period. So on our chart here, we have this, it says find the period 2 pi over k. We're going to get to that in a minute. Why is it 2 pi divided by k? Right now it's just 2 pi, that's the period. Well, if we shrink something horizontally, then the period shrinks. Okay, and this is how you're going to find it. So you got to start with factoring what k is, and again, today we're not doing this. We're not dividing by, we're going to start by dividing by k eventually. We're going to divide the periods into 4 spaces. We have a starting point that we're going to have. And then all that will make a little more sense tomorrow because we're going to get to the bigger problems that look like what we have at the top. We're going to start with simple things like this today and add a few more things to it. Okay, now let's erase that. you got to memorize what the sine curve looks like. And it's divided into fourths. 1, 2, 3, 4. Okay? Alright. That's the sine curve. Let me draw that real quickly, just to show you something here. So the sine curve went up to 1 and -1. This is your amplitude. From the middle of your graph to the top part and to the bottom part. That's your amplitude, which we say is A. The number in front of. So when I said the sine of theta, there was a 1 in front of that. It had an amplitude of 1. Up 1 and down 1. So that's how it stretches vertically. So if you remember, anything on the outside of your functions are vertical movements. Either shifting up and down or stretching it up and down. Okay? So we'll stick with the sine curve at this point, and you can just draw another one or draw on top of the one we just did. If I said 2 plus the sine of theta, again, it's on the outside of the function. Inside of the function would be right here where theta is at. That would be on the inside. And anything on the inside is a horizontal movement. We'll get to those tomorrow. Today we're dealing with the vertical movement, okay, and the length before it repeats itself. So this is your end value. It's positive, and we're going to shift the whole thing up 2 units. So that means that this point's going to go up 2 units. This point's going to go up 2 units. This is going to go up 2 units. And this is going up 2 units. And this point goes up 2 units. And then there you have your shift of your sine curve. Here's how I like to do it. I like to take my x-axis and shift it up 2 units. And I just draw a fake line there. And it helps me draw those individual pieces. So you're literally picking up your graph and moving it up or down that many units. Whatever is in front, whatever your end number is. Okay? Now let's shrink it. What if I said, what if I said 2 plus 3 sine theta? You can make another graph if you want. Okay? 3 plus 3 sine theta. Well, you know what the sine curve looks like. We just got done graphing. So now we have this number out in front of the function. And this is our amplitude. I'm sorry, this is our amplitude. We're not shrinking it yet. We'll shrink it to the next one. So now we shifted it up 2 units. This is going to be your amplitude. Amplitude stretches it or shrinks it vertically. Okay? It's on the outside of the function still. So it's all vertical movement. This picks up your graph and moves it up or down. This stretches it up or down. Up and down, sorry. So instead of this being a 1 unit possibility here, it needs to be 3 units. There's 1, 2, 3. It's going to stretch up to there. And the bottom part is going to stretch down to 3 units. So that's 1, 2, back down to 3 here. So this stretches this curve up and all the way back down to there. That's amplitude. Okay? So getting to know our position. The position way out in front doesn't stretch it or shrink it. It moves it up or down. The amplitude stretches it or shrinks it, depending on if it's a fraction or not. Remember what we said on the previous stuff when we were stretching and shrinking things. If it's on the outside of the function, it stretches and shrinks and shifts exactly the way you think it does. Horizontally, it's always backwards. If it's plus something, you're going to go negative. If it's minus something, you're going to go positive. It has a different effect when it's inside the function, and we're going to do most of that stuff tomorrow. All right, so now what I want to do, I'll erase this, we'll start this again. Oh, thank you. Any questions on that before I do another one? I'm going to add to this this same type of thing. It's going to get ugly, so I'm going to erase it and start over, okay? Alright, so let's do a different one, a different sine function instead of that one. Let's just do the sine of, let's say 4x. 4 theta, I should say. 4x is really what it's going to say in the book, but you're just plugging in your pi value for theta, okay? So if it says x, just remember that's still the same thing. Alright, so let's just see what happens here, and then I'll show you the shortcut. Alright? So here's my typical graph here. 1, 2, 3, 4. 1. There's my sine function. This is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi. Now what happens to our generic graph if we take each of these values that we had and multiply by 4? Watch what happens. At pi over 6, what is 4 times pi over 6? What does that reduce to? 4 times pi over 6.
2 pi over
2 pi over 3. Now, what is the sine function at 2 pi over 3? Where are we? 2 pi over 3 is right there. What is the y value at 2 pi over 3? Short leg, long leg, or is it a 45-degree reference? Which one is it? Short leg, long leg. It's a 60-degree reference. 2 pi over 3. Pi over 3 is 60. 2 times 60 is 120. You have a 60-degree reference. It is the long leg. Square root of 3 over 2, which is 0.87. So we're still at 0 when we started that, but at pi over 6 we're at 0.87. Okay? Before we were at 1/2. I didn't really draw this accurately. So now we go to pi over 4. What is 4 times pi over 4? Come on, wake up.
5.
Pi. What is the y value at pi? Pi. What's the y value? 0. Look at that. Something strange. Okay, what about pi over 3? What is 4 times pi over 3? 4 pi over 3. Well, there's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. What's the y value at 4 pi over 3? I'll wait. We're going to wait. Figure it out. It's on the board. There's a triangle here. Short leg and a long leg. What is the y value? Negative 0.87. Oh, so pi over 3, we're down here. Pi over 2. What is 4 times pi over 2? And what is the y value of 2 pi? 0. Not sure where the tips of those were at. But that's what happened. What happened to your sine function? It shrank, right? Shrank a lot. 2 pi over the k value. The k value here is 4. 2 pi over 4 is equal to pi over 2. Okay? That's how you find how far you're going to shift it, or how far you're going to shrink it or stretch it. Now think about this. 4 is a big number. It's bigger than 1. You would think it meant you were going to stretch it, but it does the opposite. Why? Because it's a horizontal movement. Remember, horizontal movements are always the opposite of what you think. Vertical movements are exactly what you think they're going to be. So since this was 4, you need to be thinking, okay, this is going to get a lot smaller. The only way you're going to remember that is if you start working on it. Yes.
So, we always use 5 or 6.
No, I was just getting you to see where the points were. Now I'm going to show you how easy it is to do this without doing that. Okay? I just wanted to prove to you that it was a shrink. Okay? Now here, let me do this the way I want you to do it. Okay? So, factor k, that's for tomorrow. Okay? We'll start step 2. Find the period. Period is 2 pi over k, which is pi over 2. Draw your graph, okay? Divide it into 4 pieces. 1, 2, 3, 4. My amplitude has not changed, it's still 1. You gotta watch for that, okay? So, there's my sine function, all the way to pi over 2. It doesn't look like it shrank because I just stretched out the graph. Okay? Now I want to divide it into 4 pieces. So the whole length is pi over 2. How do I divide that by 4? Pi over 2 divided by 4 is the same thing as pi over 2 times 1/4, which is what? Pi over 2 times 1/4. Pi over 8. So that means each of these is pi over 8 for a distance. Pi over 8. What's 1 pi over 8 plus another pi over 8? What's 1 plus 1, please? 2 pi over 8. What's 2 8s? 1/4, so that's pi over 4. Alright, that's 2 pi over 8. That's 3 pi over 8. 4 pi over 8 is pi over 2. I just want you to label those pieces.
So,
You don't know where 3 pi over 8 is on your unit circle. You don't know what that value is. But you do know that's the bottom. The answer is -1. The sign of that is -1. You now know. But you couldn't find that on your unit circle. Okay? My point is, whatever the period is, divide it by 4, mark your graph 4 units, and then figure out what those are. You can do that on this graph, because you're starting at 0. Tomorrow, when we shift left or right, you got to add the pi over 8 to whatever this value is. Okay, so tomorrow it's a little bit more difficult. Okay, we're going to do some more. Okay, we'll do another one. What? The reciprocal of 4 over 1. Alright, so number 1, you got to find the period. Number 2, you got to split it into 4 units. That's not how your homework starts. Your homework starts with graphing, with amplitude, and how much you shift up and down. And then the last part of your homework starts to change this. So your period at the beginning is always going to be 2 pi until you get to the end of your homework assignment, and then your period's going to shrink or stretch. Okay? It says that, just a second. It says down here the last thing is you should look at amplitude shifting and reflecting. Why would we do that last? Well, you can't really draw your graph until you know how long to draw it, right? So that's why you need to know the period first. And then you can do your amplitude, or if you're shifting up and down. You can do that stuff last. This is the best order to do it. You don't have to do it in this order. Okay?
So is the period just 2 pi over whatever the number is?
Yes, whatever the number on X
And
is.
then if there's no number, just 2 pi?
Yes. Yeah. Okay, so that's the sine. Now I'm just going to teach you the cosine curve, and this exact same thing goes with cosine. Okay, so let's learn about the cosine curve. You need to remember both of them. Let's do cosine theta. So let's draw 4 places. 1, 2, 3, 4. Those are 2 pi. The period of cosine is also 2 pi. All right. Pi over 2, pi, 3 pi over 2. And just as we're going to start out, we'll do the first quadrant of values. Finding your way all the time. Okay. Okay. Go ahead and start. Okay. So at 0, where are we? Where's the x value on the unit circle when t is 0? What is the x value? 1. So the cosine at 0 is 1. Gosh. Sorry, I got sine stuck in my brain. It's good for video. You're at 1 already. You don't start at 0. Alright? Well, pi over 6 is at 30 degrees. What is the x value at 30 degrees? The x value. You have a long leg, and that's your short leg. The long leg is x. Square root of 2 or 0.87, right? At pi over 4, everybody?
0.71.
Square root 2 over 2, which is 0.71. And at pi over 3, which is 60 degrees. What's the x value? 1/2. And pi over 2, your x value is 0. Alright, so what's happening? I don't really have these in the right place here. That's the other half of your circle. Starts at 1. We go to pi. What is your x value at pi? -1. So we go down to here. So it's going this direction. At 3 pi over 2, x is 0. So it comes back up. And at 2 pi, x is back to 1. So the cosine looks like a U-shaped graph. All it is the sine function shifted over a little bit. And it goes forever in both directions. Okay? It's just 0 to 2 pi is the period of the cosine. Okay? There you go. Page 429. Page 429, we got to do 5 to 31 odds. You have the graphs in the back of the book, so make sure you do them right.